Good morning to one and all present in the third international conference on big data and IoT 2022. And let me introduce myself. I'm Ravikumaran, a research scholar doing research in Anna University, India, and working as an assistant professor in Fatima Medical College of Engineering and Technology, Madurai, Tamil Nadu, India, under the valuable guidance of Dr. K. Vimala Devi ma'am, my supervisor, associate professor, Vellore Institute of Technology, Tamil Nadu, India. In addition with, under the valuable guidance of Dr. K. Valarmathi ma'am, my joint supervisor, professor and head, EC Department, P.S.R Engineering College, Tamil Nadu, India. Thank you. My paper is entitled as a prediction of chronic and non-chronic kidney disease using modified DBN with MapReduce framework. And here the agenda. I have organized my presentation as objective of the research, followed by introduction part, and related existing work we have carried out in the research works, which is described in proposed methodology. After that, the result, what we have obtained, and its discussions, finally the conclusion of the research work with the future direction. The objectives, the research objectives are to create and design the model using deep learning method to predict the kidney diseases, to utilize the features of distributed belief network and a restricted Boltzmann machines with a deep convolutional neural network, to establish the better classification of patients affected by kidney disease, to predict them from the critical condition, finally validating the model and ensuring the increased percentage of accuracy comparing to the earlier models. And let me go for the introduction. Nowadays, huge volume of data has produced and that has analyzed to extract the hidden useful insights using cutting edge technologies. Because of data quantity, it is difficult to process using traditional ways. Healthcare industry is one among the dealing with the extreme volume of patients, medical information that need to be monitored and maintained. The chronic kidney disease is the sixth fastest growing disease, which causes to death. And we are getting a new information, updated information that 1.7 million people are estimated to die annually. So here we proposed a work to predict the chronic and non-chronic kidney diseases. Deep belief network. The deep belief network is a statistical graphical model with multiple layers of latents, that is the hidden units, variables with the connections between the layers. The DBN can be viewed as a composition of RBMs, that is restricted Boltzmann machine used in deep learning network. And it can be formed by stacking the RBMs, that is the deep belief networks can be viewed as a stacking of RBMs. And here we have the overview of deep belief network, how the RBMs are stacked in the DBN. So here the lower layer is the input layer, the upper layer, that is higher layer, is the output layer. And there is no connection between the two visual units, and there is no connection between the two hidden units. So the every output of the one input unit is given to the output to the next hidden layer. And here this is the literature review. The literature review, we have identified the notable papers, the recent year papers, and we have identified a few gaps, research gaps from that literature reviews. The papers are artificial intelligence predicts the progressive diabetic kidney disease using big data machine learning, automation of the kidney function prediction and classification, predicting the early risk of the chronic disease in the patient, diabetics using real world data, association of pathological fibrosis with renal survival using deep learning network model, longitudinal risk prediction of kidney disease in the diabetic using a temporal enhanced gradient boosting machine, and detection of chronic kidney disease using artificial neural network and gravitational search algorithm. So here the summary of the review, I mean the literature review what we have done, and the related work what all work is carried out is so far. The neural network was developed to predict the impact of kidney disease levels. So they developed the neural networks model to predict the impact of disease level in kidney, but they considered all the parameters in the data set instead of pruned parameters. So in existing, they deployed various machine learning algorithms like decision tree, Bayesian, random forest, AdaBoost, and SVM, etc. But the accuracy can be further improved. So there is no hybrid deep learning model to predict the disease using the healthcare data. So here we are going to introduce the hybrid model of machine learning and deep learning algorithm. So this is the proposed model. So the proposed model is a prediction of chronic and non-chronic kidney disease using modified DBN with map and reduce framework by processing huge set of data without any error rate on positive and negative classes. The data set what we are going to use is the UCA repository, machine learning repository, that is University of California Irvine Medical Center data. So that data is going to be used for train the model and test the model. And this is the diagrammatic view of our proposed model. So initially we are obtaining the data from the UCA machine learning repository, that is CKD data, chronic kidney data set. And that data is what is given to our model. The model is modified DBN with map and reduce framework. And after that, the data is trained with that model and validating our model and exhibit the better results. And this is small glimpse about the data set. So we have used the data set UCA repository. The UCA machine learning repository dataset contains 25 attributes. Out of that, 14 are nominal, that is in alphanumerical and alphabets, and 11 is numerical data. And here we are classifying, the final classification is either the patient is affected by the chronic kidney disease or non-chronic disease, or he is normal, or he or she is normal. And these are all some parameters and attributes available in that data, totally 25 attributes. And here we go, the detailed diagrammatic representation of our model. The novelty of this method is we propose a MapReduce and pruning layer based classification model using the deep belief network. The remarkable connectivity features are selected through a pruning deep belief network algorithm. So the DBN are usually stacked by the multiple restricted Boltzmann machines. The bottom layer is mainly used to receive the input data, and it converts the input data to the hidden layer through RBM. That is, the input of the higher layer RBM comes from the output of the lower layer RBM. The RBM is a special case based on the energy generation model, which can be provided a learning model for the randomly distributed data. Then pruned future will be given as the input for the DBN's RBM. Generally, each RBM contains a visual layer and a hidden layer, and there is no bidirectional connection connection between the visual unit and the hidden unit. But there is no connection between the visual and visual unit, and as well as the hidden and hidden unit. So finally, in back propagation, we will incorporate the map and reduce map and reduce concept to handle the huge volume of data. The estimation of the missing values and the removal of noise such as outliers as well as the normalization and validation of unbalanced data were all part of the pre-processing. So here the input data set and that input data is get pre-processed. There we are normalizing the data. After normalization, the data is splitted into two sets. One is train set, another one is testing set, and that is given to our model. The model inside we are having three layers. One is pruning layer and RBM with the MR, that is MapReduce, and finally classification. And the output of this layer is what our predictor, I mean that predicted information, and finally it is get the performance of this model is compared with the existing model. And here we go the proposed algorithm. The algorithm contains the 5 steps. One is first step is pruning. Next step is theta updation. Third step is mapping, and fourth step is reducing, and finally is prediction. So here the input to this pruning layer is a number of epoch, that is E, and the internal hidden number of layers, that is Ni, and hyperparameters, that is how many number of hidden layers and visible layers we are incorporating to give the better prediction performance of the network. The output will be the trained by the DBN model. Here we go for the pruning. So in pruning step, we are having worker node, and that each worker node will calculate the GIF sampling. The GIF sampling, in essence, how that observed data is probability, that is distributed in probability way, so that sampling is get calculated, and finally they transfer the train network to the master node. So this is calculated in the pruning layer. And theta updation, here for each and every neuron, that is for hidden layer and visible layer, the activation function is get calculated. And third step, the mapping concept is getting executed. And fourth, reducing. So here we are updating the theta value for, so each and every time that map and reduce I mean steps will be at that process will be happened whenever that hidden and visible layer activation functions are get calculated. And finally the test data with the trained model and return the predicted data. And now I let you show the output part from our training and testing. So the here we are having the model of the data. So as I said earlier, we are having the 25 attributes. So starting from the 0 to 24 here, and here we are having 11 attributes as nominal, and sorry, numerical, and the remaining 14 as a nominal data. And this data is next convert to a normalized form. So here the next table is showed. All the data are missing data, and every data is converted into numerical format to train the data. And this is the data normalization. For the data normalization, we are using the standardized formula, that is x minus x bar by sigma, where x is the observed value and x bar is the mean and sigma is standard deviation. So all the data are converted into in between the -1 to +1. And here we are having the data processing, the finally trained data set with the pruned future subset. So this is the data obtained from our model. And here we are having the training loss. The training loss, so if you see the starting, this is the, I have shown a sample screenshot starting from the epoch 80. So in epoch 80, the training loss is 0.07. When we are increasing this epoch of the, so here I have used the epoch value, that is E value as 100. So at the time of 99th epoch, so the training loss is well much reduced, that is we are getting 0.069. And here there are certain matrices we are using for the performance analysis of our obtained model, that accuracy, precision, sensitivity, recall, specificity, and RMSE, that is root mean square error. And this is the output we got after testing our data. So the accuracy what we have got is 0.99. So it's very much pleasant information we got comparing to the existing models. See, this is the final output that we got. Accuracy we got 99%, precision is 98, recall is 99, F measure 99, sensitivity 97.9, specificity is 100, predictive value in positive way it is 100 and negative is 97. And this is the overall comparison. Sorry, this is overall comparison is compared with the traditional ML algorithms, naive Bayesian neural network, logistic and random forest, AdaBoost and SVM. So our model is predicting both chronic kidney disease as well as the non-chronic kidney disease. So our proposed model comparing to the existing, we are getting a better results. So in proposed model, true positive we got is 1, false positive is 0, precision is 1, recall is 0.97 and F measure is 0.99. So this is the case of chronic kidney disease, identifying chronic kidney disease, and identifying the non-chronic disease, we got the proposed model true positive is 1, false positive is 0.01, precision is 0.98, recall is 1 and F measure is 0.99. And this is comparison chart of RMSE, capacity statistic, and ROC. So as you all know, RMSE is root mean square error. So this is to measure for evaluating the quality of the predictions. So here we got the RMSE as 0.0125. And next, capacity statistics. This is to measure of how closely the instance is classified. So we got 0.97. ROC is receiver operating characteristics. So this is the performance of classification of R model. We got the 0.98 and the accuracy, as I already mentioned, is 99. So the conclusion of our paper research work, the methodology utilized the MapReduce algorithms incorporated with the modified DBN, that is deep belief network, to receive the predicted outcome efficiently with the trained persistent DBN with CKD data set, that is chronic kidney disease data sets. Thus, the combination of modified DBN classification with the MapReduce platform was proficient enough for giving the better outcome of both chronic as well as the non-chronic kidney disease. The efficiency is calculated in terms of accuracy, recall, sensitivity, specificity, ROC, capacity statistics, and also RMSE. Here we have future work. Our research, our research is dealing with the only the text data set, that is numerical and alphanumerical data set. So this technique can be incorporated in the image segmentation part in future. Since our proposed work was successfully able to predict even the non-chronic categories of kidney disease along with the chronic cases, predicting the chronic condition of any other similar disease could also be possible. That is, as the kidney failure could be interpreted by analyzing the diabetic retinopathy images. The vice versa also could be true. So hence the proposed method could be validated on such similar disease conditions as well. And thank you. If you are having any query, please.